Hello, my name is Neil and I am a specialist physiotherapist in the pain clinic at the James Cook University Hospital of South Tees NHS Foundation Trust. This is a brief educational video and the fourth part of a series of 7 virtual lessons. This lesson focuses on how the body's alarm system works and how it can become oversensitive or persistent long after any original injury has occurred. Throughout our bodies, we have a network of nerve endings which respond to touch, stretch, and temperature, for example. Part of that network includes our alarm system, which responds to mechanical, heat, or chemical threats. These specific nerves are called nociceptors, but we will just call them the alarm system. If you break a bone in your foot, inflammatory chemicals are released which stimulate nerve endings which send a signal to the spinal cord and then onto the brain, alerting you about a problem. This is a normal and crucial mechanism to stop you walking on the foot and doing any more potential harm. Also, the inflammation in the foot turns up the sensitivity of all the other nerves nearby, and this is a normal defense. Think of sunburn, which is temporary chemical inflammation of the skin, but a warm shower burns or light touch stings. There is no damage caused by the light touch, but the heightened sensitivity feels painful and protects you. Sometimes, when inflammation hangs around for a while, then this can mean that all the other nerves adapt and become more sensitive even to minimal or normal stimuli. We can see this in the example of joint hypermobility, where low-level inflammation around hypermobile joints can eventually sensitize other nerves so that stretch activates the alarm system. Or in osteoarthritis of a joint, where sensitized alarm signals can be triggered with overactivity and without any clear tissue damage. So now that the brain is receiving more alarm signals from this area because of the increased sensitivity, it quite rightly becomes more curious about what is going on. So sometimes nerves can adapt further, either switching their role from touch receptors to become danger receptors, or by even sprouting more alarm nerve endings. However, this can lead to a ramping up of yet more danger information being sent to the brain, and can even make pain feel more widespread. This vicious cycle we call peripheral sensitization, and while it feels out of control, it can be managed with the right help. Now let's look at the spinal cord, where the first part of the alarm system connects with the next part, and before it is relayed to the brain. This junction is influenced by a complex network of immune system cells, which can turn up or down the sensitivity of the alarm still further. We all experience this unconscious process continuously in our day-to-day activities, where the brakes can be applied to the nerves relaying information to the brain, or where the brakes come off allowing more information through. Think of the clothes that you are wearing, a watch, shoes, or your glasses. They are clearly stimulating nerves under your skin, and most of the time the brakes are applied at the spinal cord because the brain does not need to know about what your clothes are doing. But as soon as I mentioned clothes, watch, shoes or glasses, temporarily the brakes came off and you could feel those items. Let's explore this further. Have you ever picked up a hot plate, but instead of immediately dropping it, you have been able to keep hold of it a little longer and until you can put it down safely? Temperature receptors are activated and alarm signals are being sent, alerting you to the danger. But in an instant, your brain concludes that you can't drop the plate and smash it, and applies the brakes to the alarm until you can put it down safely. So while nociception is important, pain can also be felt without the alarm system actually being triggered at all. If you remember the builder who jumped onto the 6-inch nail, but the nail had in fact passed between his toes, the brain expected tissue damage and generated pain sensations that were felt in the foot to protect it. All the brakes came off and then also turned up the sensitivity of the other connections in the spinal cord, so that even flexing his foot, which was activating normal stretch receptors, turned up the alarm system. Before we look at what happens at the next stage, in lesson 5 about the brain, it is useful to follow the links below to help understand the mechanism of nociception further.